All right, so we're going to go over the Unit 6 Summative 2 review. So the very first target had to do with graphing. So there were some rules. Okay, so the A, anything in front of the function, if that was negative, that told you to flip your function. Okay, and you always flip over the x-axis. Okay, so something is like up, it flips down. Okay, the H is always inside the function, so like inside the root, and that tells you that your graph's either going to go left or right, but you always do the opposite. Okay, and then the last piece is the K, that's whatever is on the outside, so it's not in the root, and that tells you to either go up or down, and that you just do what it says. Okay, so, and again, if you need to pause me to write that down, go for it. But with these graphs, there were parent functions. So this first one is just a square root. So this is if you have a square root function, then you should have the parent graph graphed as follows. It's 0, 0, 1, 1, and 4, 2. Okay, those 3 points. So you should always just start with that graph, no matter what, if it's a square root. Okay, and then the transformation is what's happening. Well, this one has a negative in front. So if you look at that box above, that means there's a flip. And then that -2 is inside the root. So that also means we're going to go left or right 2, but you do the opposite. So that's right 2. Okay, so when you have a flip, you should really do this in like 2 steps. So you're flipping over the x-axis. So you're pretending like that line's a mirror. So like 0, 0 is going to stay on that because it's on the mirror. 1 is going to flip to the other side, and then 2, that's also going to flip to the other side. Okay, it's like a reflection. So this is just the flip, but then you have to take those 3 points and move them right 2. Okay, so I'm just shifting all of these right 2 units, and then that would be my final answer. Okay, the domain and range is always based off of that final answer. Okay, so the domain, that's always the x's. So the first x value that your graph hits is 2, and then it points to the right. So that's infinity. The range is the y's, that's low to high. This one points down, so that's negative infinity. And then the highest y value is at 0. Okay, so you do the same thing for number 2, but this is a different parent function. So again, you don't have to memorize this, but as long as you have this on your review, then you should be able to plot that on your test. Okay, so this is the parent. So maybe pause me and just graph that. Okay, and then this one has 2 things going on. So there's a -6 on the inside, and then there's a -4 on the outside. So inside means left or right, but do the opposite. Okay, so this one would mean right 6. And then it's -4 on the outside, so that would mean down 4. Okay, so this graph, you can do that in 1 step. You just move every point right 6, down 4. Right 6, down 4. Right 6, down 4. I know this one is going to go way off the graph. That's okay, just kind of guess. Right 6, down 4. Oops. And then that would be your final. Okay, and then these are nice because they point left and right, and they point up and down. Like there's 2 arrows. The other one didn't have that. So these are negative infinity to infinity every time, okay, for a cube root function. Okay, so the next target was the exponent rules. Okay, so we went through these in class, but I'll go through them again. So the negative exponents, a to the negative n. Anytime you have a negative exponent, you make it a fraction, and that exponent becomes positive. Okay, so like 5 to the -2, that'd be 1 over 5 to the second, which is 1 over 25. Okay, anything to the 0 power, that's always 1. Now this, the x to the 0, that 0 is only stuck on the x, that part is 1. So this means 4 times 1, which is 4. Okay, product of powers. So if you multiply with the same base, then you add the exponents. So 7 plus 12 is 19. Anything outside parentheses, you distribute. So that means multiply. So this would be y to the 12th. Okay, this also means distribute, so this would be a to the m, b to the m. So this one, you just want to be careful because this would be 3 to the third. Don't forget the 3, and then x to the third. And you could use your green sheet. 3 to the third is 27. Okay, anything with division means subtract. So this would mean a to the m minus n. It's always top minus bottom. So this is x to the 9th. This is 14 minus 5. And then the last one, again, distribute. So that's a to the m over b to the m. Okay, so if there's already something there, then that's the rule before, or 2 rules before, I guess. So 2 times 5 is 10, and then 8 times 5 is 40. Okay, so again, if you need to pause me, pause it here, write those down. Okay, so then there's some examples. So these are all different, right? But this one would mean multiply. So this would be -2 times -4 is +8. 3 times -4 is -12. Okay, now the problem with this one is you can't have a negative exponent. So you could just think about this as a fraction, and to fix that, you move the negative exponent down. So the x to the 8th stays where it is, but the y to the 12th goes to the bottom. Okay, you don't move the x to the 8th because that's positive. All right, number 4. This one you can do lots of different ways. I like going across first, so I'm going to do the top first. Okay, so I'm going to combine like terms. So 2 times 5 is 10. Okay, there's an a and an a squared. Well, a times a squared, that's like a to the first. You add those exponents, so that's a to the third. And then you do the same thing with the b's. Add those exponents, that'd be 13. And then do the same thing on the bottom. Okay, so 14, there's no other number. There's no other a's. But then there would be 8 b's because you add those. Okay, now this is not done because you have a's on top and bottom and b's on top and bottom. So for that, I'm going to subtract. So I'm going to leave the 10 and the 14 for now. But 3 minus 6 is -3. That defaults to the top, always. And then 13 minus 8 is 5. Okay, now there's a couple problems with this. I can't have that negative exponent, so I need to move it down. Okay, and then the 10 and the 14, you can also divide those both by 2. Okay, so 10 divided by 2 is 5, 14 divided by 2 is 7. That a to the third would move to the bottom, b to the 5th can stay where it is. Okay. Number 5 is a lot like the one in the box. That 0 is only attached to the x, so that's 1. So this is 12 times 1, which is just 12. Okay, and then number 6, again, a lot like the one in the box above. That 3 gets distributed, but it's not 5 times 3. It's 5 to the third, and then 4 times 3 is 12, because that's an exponent. Okay, you could look at your green sheet. 5 to the third is 125. And then that would be my final answer. Okay, so that's the second target. That's the exponent rules. All right, the top, this is really just the green sheet, so I'm not going to fill those in, but the rest of this is simplifying. Okay, so when you have your green sheet handy, you just want to make sure you're looking at the right column. So number 7 is the square roots. That's the first column. Okay, so I want a number that goes into 28, which would be 4. I can do 28 divided by 4, and that's 7. Square root of 4 is 2, so this is 2 root 7. Okay, number 8, same thing, but this is the cube roots. Now, before you just do this, if you notice in the list, that is a perfect cube. So I don't need to break that into 2. It's just a nice answer. It's 5. That's it. Okay, now number 9, that one is not in your list. 128 is not in the list. So that one, that's an example you have to break up. Just make sure you put the little 3s on there. And you can divide numbers. If I do 128 divided by 125, that's not nice. I can do 128 divided by 64. That gives me 2. And the cubed root of 64 is 4. Okay, so that would be my final answer. So a few more of those. If you have a number in front, you can just kind of ignore that number. So if you look for a cubed root of 81, that would be 27 goes into that 3 times. Cubed root of 27 is 3, so you get 3 cubed root 3. But the 4 in front, we bring that down, and remember we multiply outside numbers. Okay, so 12 cubed root 3 would be your final answer. Okay, similar, number 11, 4th root of 512, that's not in my list, but 256, oops, goes into 512 2 times, so this would be 4th root 2. And then last one kind of that group, again, ignore the 5, but the 4th root of 16, oh, that's 2, that's just a nice number, so I don't need to break that down. But there was a 5, so 5 times 2 is 10. Okay, next is when you mix variables and numbers. Okay, so you can kind of do these separately. So like cubed root of 54, and then the letters. Okay, so cubed root of 54, I can break that down. 27 goes into 54 2 times. Cubed root of 27 is 3. So I'll come back to that. So 3 cubed root 2. For the letters, so the 3 is your magic number. Okay, so you want to write x to the 5th with as many 3s as you can. So I can write 1. I can't write another because that would be 6, but there would be 2 left over. Okay, so that's the same as 5. And then I can do the same thing with the y's. So y to the 3rd, that's 6, and then there's 2 left over. So whatever has a 3 on it, I can take that out. So there's an x, and then there's 2 y's. Those can come outside. Okay, and then whatever's left in the root, I have to keep that. And then you can combine your answers. So this 3 is outside the root, so that would go outside my answer. And then this 2 is inside the root, so that would go inside here, and then that would be my final answer. Okay, so just a couple more of those. Number 14, so 4th root of 16, and then 4th root of a to the 9th, b to the 3rd, c to the 7th. 4th root of 16 is 2. I'm going to write everything here with 4s. It'll be 8 with 1 left over. Now, 3 is not 4, so I can't rewrite that with the 4. That's too small. Okay, there's 1, 2, so that's a squared. C, it's the only thing that I can take out. And then there's the 4th root of a, b to the 3rd, c to the 3rd, because those stay in. But then this 2 was outside, and there was no number left in the root. So that's it. That's your answer. All right, last one of this type. So this is the same thing, just with a 5. And you might be able to just kind of jump to this and say, hey, if I wrote these all with 5s, x to the 15th, I know that there's 3 of those that are going to come out. Okay, and then y to the 27th. Well, 27 divided by 5 is 5. So I know I'm going to be able to take out 5 of those, but then there would still be 2 left over. Okay, so that's one way to do it. I do like seeing all the writing, but I know 27 is kind of a big number. Okay, again, you can pause me, you can go back if I'm going too fast. So the last parts were adding and subtracting and then multiplying. Okay, so this is, you can only add and subtract like terms. So I need to simplify first. Okay, so square root of 48, I go back to my square root list. You can do 16, that's 16 times 3, which is 4 root 3. Bring down the 2, so that's 8 root 3. Okay, cubed root of 32, 4 can go into that. Oops, that goes in 8 times. So that's 2 cubed root 8. Oops, I did not do that right, sorry. 8 goes first, 4 times. So that's 2 cubed root 4. And then the 108, cubed root of 108, 27 goes into that. I'm kind of doing the calculator work for you here. That would be 4 times. Okay, so that's a nice 3 cubed root 4. So right now you have 8 cubed root 3 plus 2 cubed root 4 minus 3 cubed root 4. So these right here are like terms. So you can't do anything with the square root of 3, but 2 minus 3 is 1. So this would be your final answer. Okay, and then the last one is multiplying. Multiplying, you multiply first, and then you can simplify. So 4 times -3 is -12. Cubed root of 5 times 25, that's 125. Okay, then simplify. Well, the cubed root of 125 is 5. If I go -12 times 5, that's -60. Okay? So hopefully this helped you. If your review's all done, you feel ready, you can let me know when you're ready for a retake. Okay? Thanks.